Hang on, so 9.1 is something new. This is what we call the composition of functions. So let me let one more in here. Hang on, so when we talk about the composition of functions, the composition of functions is when one function is put into the other functions for the variable. So the composition of functions is when a function is put into the other function in place of the variable. Okay, so we're not just putting a number in this time or expression, we're putting a whole function into those x's, okay? So we got two types of order on this. The first one, we got what we call f compose g of x. So y'all, that's not an O, that's like a little degree symbol. And this is the symbolism for the composition. So this is f compose g of x. So this would be like f of g of x. So notice for the f function, I'm putting the whole g of x into each of its variables, okay? So for this notation, the function g of x is put into the f function in place of the variable. And then y'all, they go the other way. The other way would be g compose f of x. All right, so g compose f of x is like g of f of x. So when we got this notation, the f of x function is put into the g function in place of the variable. So the function f of x is put into the g function in place of the variable. Now, the second part of the homework, we'll be doing this without them giving us numbers. But for the first, I think the first three problems, they actually give you numbers, and they'll do like an f of g of 5 or a g of f of 5. So if numbers are given, all right, so if numbers are given, first we'll look at F compose G of some number A. So say they gave me some number A, and we'll just use the A to represent any number. But y'all, if they give me a number instead of an X here, the first thing we do, because remember, this is like F of G of A. But they give me a number for A, so that means if they give me a number, the first thing I'm going to find is the G of A. So first, find G of that number. So now, once I've plugged a number into the G function and got an answer out of that, I then put that answer into the F function. So put the answer from above into the F function. All right, then evaluate and be done. So evaluate that expression. And y'all, then we'll be done. Now, the same thing goes if this was G of F of A. If this was G compose F of A, I would first find F of A and then take that answer and put into the G function. Okay, so the same thing. What they give us determines our order on these, okay? So y'all, let's start working some of these examples. Now, these first examples, like I said, they're going to give us numbers on these, okay? So let's start out. Let's let f of x equal a negative 3x minus 1. Our g of x is going to equal x squared minus 2. They want us to find f compose g of 7. So y'all, this notation is the same thing as finding f of g of 7. So we start with the g of 7 first, like we said here. We start with the number they give us in the g function. So the first thing I'm going to find is g of 7. Once we find g of 7, we'll put that into our f equation. All right, y'all, so g of 7 will equal our g equation, and we're going to put a 7 in for that x. So that's going to give us 7 squared minus 2. All right, so we're just going to play with order of operations. Exponent first. 7 times 7 is 49 minus 2, which means g of 7 equals 47. So now that we got 47 out of the g of 7, the second thing we do, we're going to find f of that 47. So it's like you're substituting that number twice. You're plugging it into the first equation, getting that answer, and plugging it into your second equation. So we need f of 47. That'll be my f equation, and I'm going to put a 47 in for that x. So that'll give me negative 3 times 47 minus 1. All right, y'all, let's see. Negative 3 times 47 is a negative 141 minus 1. So a negative minus a number gives me a negative number. So let's see, 141 negative minus 1 gives me a negative 142. This is the answer that we want to put in MATLAB. Okay? So remember, compositions are 2 steps. 7 into the G, then that answer into the F. All right, y'all. Y'all got a question on that one? All right, y'all, let me pull my chat over. All right, so y'all go. So let's try another one of these. Now, y'all, I'm not gonna lie, they're not too bad with numbers. Where these problems get tricky is when we start getting into just having variables versus the numbers, okay? All right, so let's see what they want on the second one here. So on this one, we'll be given f of x is going to equal 2x plus 4. G of x is going to equal x squared minus 3x minus 5. Now, y'all, on this one, they want us to find G compose F of, oh, what is that, a 6. So remember, this one, when they give us G compose F, is like finding G of F of 6. So first, we'll find F of 6. Once we figure out what F of 6 is, we'll put that into our G. So we're finding F of a 6. So we take our F equation, put a 6 in for that X. So y'all, F of 6 will equal 2 times 6 plus 4. All right, so y'all, what's that? 12 plus our 4. That's going to give us
16.
16. There you go. All right, since F of 6 gave me 16, now we're going to find G of that 16. Woo, y'all, that's going to be big, and I got exponents in here. Woo, we're about to square that 16, it looks like. So, so we're going to throw a 16 in for both of these x's. So G of 16 will equal 16 squared minus 3 times 16. And y'all, 16s are hard. I went to school in Arkansas, and we always stopped at 12 times 12. So we didn't quite make it to the 16. So let's see. 16 times 16. What's that? 256.
Yes, 256. Yeah.
Minus, so this part will stay negative because I got a negative 3 times 16. That'll be minus 48. And then minus our 5. All right, y'all. So let's see. 256 minus 48 minus 5. I'm getting something like what, a positive
203.
203.
Mm-hmm.
And that 203, y'all,
Mm-hmm.
is what MATLAB wants, okay? Yeah, I didn't ever think these were too bad, except wait till about number 4, then they start turning up the heat on us. Now, y'all, like I said, the main thing is keep up with the order they're going in. Is it F compose F? F compose G or G compose F?
Okay.
All right, so we got one more of these. So this one we're given F of X equals 3x plus 4. G of X is x to the 3rd They want us to find F compose G of a -3. All right, so remember, this notation is like F of G of -3. And the reason I write them like this is so that I can see order of operations. You always start with the innermost and work your way out when all that stuff's in parentheses. So the first thing we find is the G of -3. All right, well, G is just the x to the third. So that's going to be a -3 to the third power. And y'all remember, negative times a negative times a negative. When you got an odd number of negatives,
Yeah.
that will stay negative.
Yeah.
And then what we got? 3 times 3 times 3. So that'd be what, a negative?
27.
27. There you go. So G of -3 is -27. We now put that -27 into our F. So I'm going to find F of that -27. All right, y'all. So F of -27 will be 3 times our -27 plus 4. Ooh, okay, y'all. They're giving me some numbers today. Let's see. That's what 60. That's a -81, I think.
Yep.
And then add 4 to that. So remember, we got unlike signs again, but the larger number is negative, so I know that'll be a negative. And then what's that? A negative
77.
77. And y'all, that right there is the final answer for Math Lab. So y'all, these first 3 not bad. They'll give you a number, plug it into the function you need, take that answer, plug it into your other function. All righty, so now let's look at the next few problems. But before I can do that, we're going to learn another way to do our domains. Okay? Because remember, right now for the domains, when we did all real numbers,
Yeah.
we did X such that X is a real number.
Yes.
Well, this notation, when we write it like this is called set builder notation. But it's sort of long writing out all these words. So we're going to look at another way to represent our domain for all real numbers and how to kick out a number. Because remember here, if I wanted to exclude a number, I had to say, hey, X is a real number and X cannot equal 5, 6, or whatever.
Right.
So y'all, what I'm going to show y'all what we call interval notation. Now, I don't know if y'all are familiar in the past, but in the past, when y'all was doing like number lines and stuff, and y'all had like X was greater than 5, or X was greater than or equal to 5,
Yeah.
y'all used curvy brackets and y'all used square brackets. Well, y'all used the curvy brackets when it was either less than or greater than. Y'all used the square brackets when it was less than or equal or greater than or equal. So if we use parentheses, that means it does not include that number. Now, if I use brackets, it does include that number because of the equals. So interval notation sort of plays with this parentheses, okay? So let me show you how we represent all real numbers and then how we kick out numbers. So in interval notation, all real numbers is represented by, so y'all let me ask you this. If I'm heading into negative direction and I keep getting more negative and more negative, what do we say we're headed off towards the more negative I get? And y'all, that would be negative infinity, right?
Infinity, yeah. Mhm.
Oh, yeah.
Remember,
Mhm.
negative infinity means I'm going negative and I never can stop because there's always going to be another number more negative.
Yeah.
Now, if I'm headed off to the right, I'm headed in the positive direction.
Infinity. Mhm.
I'm headed towards positive infinity. So if I give you this negative infinity to infinity, that represents all real numbers. Now, the reason they don't have brackets on these infinities is because I can keep getting more negative and negative or more positive and positive, okay? So now this is how we represent all real numbers now. Negative infinity to infinity. But what if I want to exclude a number? To exclude a number from the domain, we use parentheses. Because remember, parentheses means it does not include that number like the square brackets. So we use parentheses and the union. Now, y'all, the union looks like a U. And that means and. So, for example, to exclude any number A, from the domain, we would have, and y'all, they're all going to start at negative infinity. So you're still starting at negative infinity, but to kick out this number A, I go from negative infinity up to A, curvy parentheses. Remember that curvy parentheses means we do not include the A. And then we're going to union, because remember, we're going from negative infinity to A, and I can start on the other side at A, but not include the A, and head towards positive infinity. So this is how we exclude any numbers here using the little union here. So my domain is from negative infinity up to A. And it starts on the other side of A, but don't include it, remember, because of the curves. And from the other side of A, it heads towards positive infinity. It's not too bad. Just remember, I have to have a union for every number that I kick out, okay? And I got to go in order from left to right with my numbers, okay? So y'all, that's going to get us ready for the next few sets of exercises here. All right, y'all, let me get the paper done. So, y'all, for these examples, let me move back up. For these examples, they want us to find F composed G of X. So they're not giving me a number. And they want us to find G composed F of X. And the domain of each. Okay, so they're going to give us a f of x, a g of x. We're going to find f compose g, then we'll find g compose f, and then we'll look at the domains of each.
Okay.
So now I'll see how you are getting on my domains. So f of x will equal x plus 17. G of x is going to equal x minus 17. So they're starting this out sort of mellow here.
Yeah.
So let's start out finding f compose g of x. Now remember, f compose g of x is really f of g of x. So first we got to find our g of x.
Mm-hmm.
But y'all, guess what? They didn't give you a number here. So if they didn't give me a number here, can you do anything to that g of x?
No.
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 So here's the trick. Since I can't do nothing to this x minus 17,
Mm-hmm.
this whole function will now go into the f of x. So put x minus 17 into the x of f of x. Okay? So here, so that means technically we're finding f of an x minus 17, right? Since g of x was x minus 17, we couldn't do to it anything. So that means we're going to find f of that x minus 17 now. So that means wherever I got an x on the f equation, we're putting this. We all starts right off with an x. So in place of that x, I'm going to put x minus 17. And then at the end, we still got a plus 17.
Plus 17.
So y'all with me? I got my g of x put in for the x plus my 17. Well, can y'all simplify that down?
X
Well, one
minus,
thing's happening on that.
X minus 1.
Is it X?
Oh, it's just an x, right?
Mm-hmm.
Because see, these negative 17 plus 17,
Cancel out each other.
they're going to cross out and cancel each other out. So that means f compose g of x equaled x. So then they said find g of f of x. So g compose f of x. So this one will be like g of f of x. Well, y'all, here's the f of x. We can't do nothing to the f of x because they didn't give me a number. So that means this x plus 17 is going to go into the x for the g of x.
Mm-hmm.
I'm going to put x plus 17 into the x of g of x. So if I'm putting x plus 17 into its x's, that means I'm finding g of an x plus 17. So these compositions, notice, it's the whole function that we're putting in, right?
Yeah.
So let's find our g equation. It's an x minus 17. So we said in place of that x, we got to put our x plus 17. And I still got a minus 17 at the end. Well, look what happens on this one. Really, since these were sort of opposites of each other, that's why we keep ending up with a,
X.
what do we get on this one?
X.
X.
It's going to be an x again. Good job. Because once again, those
Cancel out.
cancel out. Now, they won't always do that, but on this number 4, I'm pretty sure if you get an x plus something and an x minus that same number, You're going to get the same things I got here, okay? So the domain. Let's see what y'all remember about a domain. So we'll start with f of g of x. Here's my f of g of x, x minus 17 plus 17. I ended up with an x. But the question, what's that domain? What's the one thing that I don't see in this problem?
A fraction.
A fraction. Remember, that's the only thing I'm worried about is the fractions, right?
Right.
If you have no fractions here, that means your domain is?
Real numbers.
Real number.
And we're going to write that now as what? A negative infinity to a positive infinity. All right, well, here's G, compose f of x. X plus 17 minus 17 simplified to an x. What's that domain?
Same thing.
Isn't it the same negative?
Thing, yeah.
infinity?
Negative infinity, and good job, y'all. And we still see no fractions. Remember, that's the only thing we're worried about in life right now is a fraction, okay?
Mm-hmm.
All right, y'all, so let's see. We're doing the same thing here, but this time they're giving us f of x equals x plus 3. G of x is going to equal 2x squared minus 5x minus 3. Okay, so we're still finding f compose G, G compose f, and the domains of each of these. So once again, I'm going to start with my f compose G of x. And y'all remember, that's f of g of x. So I'm starting with g of x. 2x squared minus 5x minus 3. They didn't give us a number to put in. There's nothing we can do to that. So y'all, that means this whole function is going to go into that x.
Mm-hmm.
So that means we're finding f of a 2x squared minus 5x minus 3. Okay, because that is g of x, right? This
Yep.
whole thing. So there we go. So here's the x. Guess what we're putting in? So we got 2x squared minus 5x minus 3. And then at the end, we got a plus 3.
3.
So it still looks like f of x. I got a big X plus my 3 now. All right, y'all simplify that, and what do y'all get?
Let's see.
2x squared minus 5x.
2x squared minus 5x. Y'all,
Yeah.
once again, them numbers sort of canceled out on us,
Yeah. Mm-hmm.
and that's our final answer.
Mm-hmm.
Okay. All right, now, next one might not be so fun, but let's do this g of f of x. G compose f of x is like a g of f of x. All right, well, f of x is an x plus 3. Can't do nothing to that. But y'all look here, I got 2 x's, and in place of each of them x's, I'm going to put that x plus 3.
Okay.
So this means we're technically finding g of x plus 3. All right, so take your g equation and put that x plus 3 in for each of these x's. So I got 2 times x plus 3 squared minus 5 times x plus 3 minus 3. So since g's the main function, look how it still looks like it. 2x squared minus 5x minus 3. It
Mm-hmm.
still patterns the g function.
Mm-hmm.
It's just the x is a little bigger. So y'all, let me ask y'all this. Where in the world would y'all start on this?
With the exponent.
The exponent.
Yeah.
Now, what does the x plus 3 squared give us?
Wouldn't it
X squared plus
be?
9.
Well,
Would you bring down your x?
so let me show y'all what you got to do to this x plus 3 squared.
Mm-hmm.
Now, x squared plus 9 ain't all of it. When y'all see something like this, x plus 3 squared,
Yeah.
remember, that means the x plus 3 times
X plus 3.
x plus 3.
Oh,
So see, we're missing a little bit if we just square the x into 3.
yeah. Okay.
Mm-hmm. So we would do our x times x and get an x squared. X times 3 gives us a 3x. And then I distribute my 3 times x, I get a 3x. And then the 3 times 3
9.
is a 9. So you got the x squared and the 9, but make sure you FOIL these out because you need these x's in the middle also.
Yeah. Okay.
And y'all, those are like terms. So you're going to get an x squared plus a 6x plus 9. Now, I will say this. You can distribute exponents, but when you distribute exponents, you got to have stuff like 3x squared, maybe to the third. If everything's being multiplied, then you can distribute the exponent and be done. But what's hurting us is that adding on this one, okay? Alrighty, so this now replaces the x plus 3 squared. So that's going to give me 2 times x squared plus the 6x plus the 9 minus 5 times the x plus 3 and then minus R3. So we cannot do anything in the parentheses. We've taken care of the exponent. So now we're going to multiply. We're going to distribute this 2 through the first parentheses. We'll distribute the -5 through the second parentheses. And then at the end, we'll bring down that -3.
Okay.
So y'all, let's see, that's going to give us a 2x squared. 2 times 6 gives us 12x. 2 times 9 gives us 18. Now remember, this is -5 times x, which is a -5x. That's -5 times 3, which is -15.
Yeah.
And then bring down that -3.
So, yeah.
All right, so I'm just going to write my order in what I call descending order. So I'm going to start with the highest exponent. And there's nothing for it to add to. So I'm going to bring down my 2x squared.
Mm-hmm.
All right, what's next?
Plus 12x minus 5x.
So let's see. 12
Plus
minus 5.
an x.
And then that takes care of my x's. So now I got the 18
And 15 and 3.
minus the 15 minus the 3. Ooh, well, guess what?
Cancel out each other.
Yeah, that -18 here cancels that 18. So our final answer is 2x squared plus our 7x.
Yep.
Okay, y'all. So that's sometimes if these functions are big and you got these x squareds, be careful if I'm giving you a binomial, we call it. When you square those binomials, you got to FOIL those out, okay?
Okay.
All right, so let's look at the domain of our f composed g of x. So that was this one, f composed g of x. I had 2x squared minus 5x minus 3 plus 3 simplified to a 2x squared minus 5x. What is that domain?
But there, Let me think.
Well, y'all, there's one thing I'm looking for and I don't see it.
Fraction
Yeah, I don't see fractions again.
is the real
So
number.
it's a
Uh-huh.
real number. So
Mhm.
So
negative
definitely all
infinity
real
to
numbers on
positive.
those, okay?
Yeah.
You're gonna see that all these functions are this unless you got a fraction, okay?
Mm-hmm.
So the domain of G compose f of x. Well, here with G, I got some squares and stuff, but I still don't have fractions in this. So the domain is,
Negative infinity to positive infinity.
there you go.
Yep, gotcha.
They're not too bad. You just got to sort of keep up with, do I got fractions? Because if you got a fraction, it's possible that the denominator could be a 0, okay?
Yeah.
All right, y'all. So, when they're doing domain problems, eventually they're going to give us fractions, right?
Mm-hmm. Mm-hmm.
So same thing, but this time they're giving me f of x equals 2 divided by 1 minus 9x. G of x is going to equal 1 over x. So look, they gave us 2 fractions.
Mm.
So I'll start out with my f compose g, then I'll do my g compose f, and then we'll find those domains.
Okay.
So y'all, f compose g of x. Remember, that's like f of g of x. Well, here's g of x. They didn't give us a number. We can't do nothing with that. So this 1 over x is going to go into the x of my f. So basically, we're finding f of a 1 over x. So take my f equation, 2 divided by 1 minus 9 times my x, which is 1 over x. Now, I'm not going to lie. This last one you got, your number 6, the trick on this is trying to simplify this, because we need to make this look like a numerator over a denominator. We
Okay.
cannot have fractions inside of fractions. This
Okay.
is what we call a complex fraction.
Mm-hmm.
And to simplify it, we need to make it look like a normal fraction.
Okay.
So the first thing I would do here is multiply this right here. Now, treat the 9 like it's got a 1 on the bottom of it, okay?
Yeah.
So the top will stay 2 divided by 1 minus, well, when you multiply fractions, straight across. So 9 times 1 gives me 9 on top over 1 times x, which is x. Now, all we did here, we multiplied the fractions. But if you notice, I still got a fraction inside my fraction.
Yep.
So let me ask y'all this. If I wanted to multiply by something that would cancel this fraction, sort of, I need to get rid of this denominator here. So since that denominator is an x, I'm going to multiply everybody by that x.
Oh.
Now remember, multiplying on a fraction, you got to do to the top and bottom, and you got to distribute. So all 3 of these, I'm going to multiply by the x, okay? So I'll have 2 times x on the top, 1 times x minus my 9 over x times x. Remember, multiplication is distributive, and it's got to be done to everybody. Well, y'all, let's see if this works. On top, 2 times x is a 2x. On bottom, 1 times x is x. But y'all, what happens here? What about these x's?
Don't they cancel out?
They're going to cancel out. So that's just going to be an x minus 9. Now, I got a numerator. I got a denominator. I don't have extra fractions in that. So guess what, y'all? This is our
Answer.
final answer. So let me write what I actually did here. So right here, I multiplied top and bottom by x to cancel the fractions. Denominator. Okay, because that's all I had to do to that, cancel that denominator out, and then I'd have a normal looking fraction. All right, so let's find g of f, and then we will look at our domains, okay? So g compose f of x, y'all, is going to be g of f of x. Well, y'all, here's f of x. You can't do nothing with that. So that means this whole f of x function here is going to go into that x. So we're finding g of a 2 over 1 minus 9x. Right? Because that's the whole function I'm putting into the x right here.
Yeah.
So y'all, that'll give you 1 divided by 2 divided by 1 minus 9x. So once again, I got a fraction inside of a fraction. Now, notice over here, I had an x on the bottom. I multiplied top and bottom by that x. We're over here, look what I got in bottom. I got a 1 minus 9x in the bottom. So what I'm going to do is multiply the top and bottom by that 1 minus 9x. So on top, I got 1 times 1 minus 9x. So if you see, to cancel fractions, you're just knocking out them denominators, okay? So the bottom was 2 over 1 minus 9x. And we got to multiply it by the 1 minus 9x. So basically, 1 times anything on top, 1 times 1 is going to be 1.
1.
And then that 1 minus that 9x is going to be what? Minus 9x. But y'all, what happens to the bottom? This 1 minus 9x and this 1 minus 9x.
Cancel out each other.
And all that's left is a
2.
2. There you go. So now I got a normal fraction. So now I can be done. So the moral of the story, to get rid of these extra fractions, over here now, notice, over here I had 3 parts. So I multiplied all 3 parts by the x. Over here, this 1 minus 9x was the only denominator. So I multiplied the top and bottom by that, okay?
Mm-hmm.
Well, guess what? This domain can't be all real numbers here. Right here, you got a 1 over x. Right there. That x cannot equal what?
Infinity.
Oh, what I hear? What's the only number that x cannot be? Well, what would make that undefined?
0.
A 0. So that x right there cannot equal 0, right?
Mm-hmm.
So that means we're kicking 0 out of our domain.
Yeah.
But y'all look further at this final answer. What can this x not be? Because remember, this denominator can't equal 0 either. So what number will that x be that makes this part equal 0?
9.
So we know now x cannot equal 9 right there.
Correct.
So if you see, I got two places I got to worry about. I got to worry about this first x not equaling 0. I've got to worry about this x not equaling 9. So for my domain, I'm still starting at negative infinity. So now, going left to right, who's next? 0 or 9?
0.
Okay, so I go from negative infinity up to 0. We're going to union around our 0. So now we kicked out the 0.
Mm-hmm.
So now we're still cruising along the x-axis until we hit that 9.
Okay.
We got to kick out that 9. So we're going to union around our 9. So notice, one union kicked out to 0. The second union kicks out to 9. And from that 9, I'm headed off towards
Infinity.
infinity. There you go. Okay, y'all, so that's how you kicking out the numbers. So that was domain of F compose G. Now let's look at the domain of G compose F. Well, I got a variable in the bottom here. So we need to figure out what this X cannot be. So y'all, this one's trickier than this one was straightforward.
Yeah.
This is pretty much straightforward. But right here, this 1 minus 9x, what I would do is set that 1 minus 9x equal to 0 like we did last week. Solve that for the x, and that'll give me a number to kick out. So here I'm just going to subtract 1. I get negative 9x equals negative 1. Divide both sides by negative 9. And y'all look, that makes me a positive 1x. Negative divided by negative makes that a positive 1/9. That means if you put a 1/9 in here, the 9's cancel. 1 minus 1 makes that a 0. So
Mm-hmm.
we got to kick out this 1/9. And y'all look, all I got on bottom here is a 2. There's no way to turn that 2 into a 0. So that means I've only got one number to worry about, which is that 1/9. So our domain will be from negative infinity to the 1/9. We'll union around that 1/9 and head off towards positive infinity.
Mm-hmm. Makes sense.
So this problem's trickier of the two, but on the F of G, you're going to get two numbers to kick out like I did. That initial X, because y'all's G of X will probably be 1 over X like mine. So look at the initial X, and then at the end, you're going to have a X minus some number. On your G, the only place you're worried about on G is right here in the beginning. It's the only place where I had a variable in the denominator of the fractions. Okay, over here, the X is on top. All that was on bottom was a 2, so we wasn't worried about that one. Okay.
Okay.
All righty, so that is our college algebra 9.1. So now I'm going to show you the support problems. And on the support, they had two problems we had to do. So y'all, this will be 9.1 support. All right, so for the first one, they're going to give f of x equals x plus 15. So they're giving me a function, and they want me to find f of 0, f of negative 11, f of negative 10, f of 13, and then f of a x plus 9. Now when you're doing it in MATLAB, it gives them to you one at a time. So it'll start out saying, hey, find f of 0. When you put that answer in and check it, it'll then say find f of -11 and so on.
Okay.
So y'all, f is 0. Well, guess what? They want me to put a 0 into the f function and see what I get. So that's going to give me a 0 plus 15. And that's going to be 15. So I punch that number in and it gives me the next one, which is f of -11. We all put a -11 in for that x. You get -11 plus 15. And really all this was getting you ready to plug in stuff in, okay? All right, unlike signs. So what's that? -11 plus a 15.
4.
Okay, so that's going to be a 4. What do we got next? F of -10. So that's going to be -10 plus 15. And y'all look, I'm working all these the same way. Putting a number in, adding 15. Put a number in, add 15. Put a number in, add 15. All right, so -10 plus 15.
5.
All right, then now I got a positive number, f of, what is that, 13. So 13 plus 15, and y'all get
28.
28. And then finally for this one, f of x plus 9. So this would be sort of like if he's putting something like this into that one we had that square a while ago, remember? So f of x plus 9, I'm going to put an x plus 9 in for that x. I'm going to get an x plus 9 plus my 15. So what y'all doing to that?
You're gonna bring down your x.
I'm going to bring down my x. And then what you doing with that?
24.
Plus
Uh-huh,
It'll
20.
be 24.
Do you good. Good job. Okay.
Yep.
So your first one, there's only 2 problems in support for tonight. So the first one, but that's like 5 problems in one. Now the second one, we're given f of x equals 3x squared minus 4x. So for this one, they wanted me to find f of 0, f of a -1, and then f of a +2. So they were good to us on this one. They didn't give us none of this x plus 9 type stuff, because if they would have gave me an x plus 9 or something like that, I'd had to do some foiling on this one. But y'all, they didn't give me no variables, just 3 numbers to throw in. So let's start with f of 0. Well, y'all, that'll be 3 times 0 squared minus 4 times 0. We already got a lot of zeros here.
0.
So that's going to be a big 0, right? Because 0
Yep.
here cancels everything.
Yep.
0 here. That's
Yep.
gonna give us. So check this out. If you're finding f of 0, g of 0, and you got a variable in every one of the terms, it's always going to be 0, okay?
Correct.
All right, so let's find this f of -1. So 3 times -1 squared minus 4 times your -1. So remember here, start with that exponent. So bring this 3 down. So -1 squared.
1.
1.
Right, and I'm just bringing everything else down for the second. All right, so now I'll multiply this stuff. So 3 times 1 will give me a 3.
3
This is like a -4 times a -1.
plus 4.
And y'all, 3 plus 4, final answer of
7.
7. There you go. All right, and finally I had f of 2. So 3 times 2 squared minus 4 times our 2. Now, y'all, I'll tell you the biggest mistakes that I get on this is people multiply that 3 times 2 before they do the exponent.
No.
No, there you go. Start with that exponent.
Don't want to do that.
Mhm.
Let's see, 2 squared.
4.
4.
All right, and I'm just bringing everything else down. All right, so now I'll do all my multiplying. So let's see, that's be 12.
12. Mm-hmm.
And this one will stay negative. That's like a negative 4 times 2, which is what, a negative 8.
8. Yeah.
And then final step, just subtract and be done, and we get a
+4.
+4. There you go.
Yep.
So the support, like I said, is just to get you better at plugging stuff into them functions and coming up with your answers, okay? So 1, 2, and 3 shouldn't be too bad on the college algebra 9-1. Even 4 wasn't too bad. Remember the x plus 17, x minus 17. Where you got to start thinking is on that number 5 and 6, okay?
Yeah.
All righty, y'all. So I'm going to stop my share here. And I'll stop recording, and then I'm going to see what all y'all got questions.